Here are three motion problems which we can solve using our kinematic equations. Let's take a look at the first problem. A car has an initial velocity of 4 meters per second. It accelerates at 4 meters per second every second over 20 meters. Find the final velocity of the car at 20 meters. Well, the first thing we do in all these kinematic problems is put down our kinematic equation variables and put them in an ordered list. So we start off with u, our initial velocity, v, our final velocity, a, our acceleration, s, the displacement, and t, the time. Read over the question again and fill in as much data as you can. The car has an initial velocity of 4 meters per second. It accelerates at 4 meters per second every second. 4 meters per second every second. Find the final velocity of the car. Have to do that. Question mark at the variable we want to find. And we know that the displacement is going to be 20 meters. So we're looking for an equation which has got the initial velocity, final velocity, acceleration, and displacement. So let's check our equation list, our kinematic equation list. And here it is here. We're looking for something with u, v, a, and s. And it looks like it's going to be this one here. U, v, a, and s. We've got it. Put down the equation. V squared equals u squared plus 2 times acceleration times displacement. Now we don't have to rearrange anything because what we're trying to find, the final velocity, is on the proper side of the equation. So v squared is going to equal to u squared, which is 4 squared, plus bracket 2 times the acceleration, which is 4 meters per second every second, times the displacement, which is 20. Okay, we've got v squared equals 16 plus 2 4s are 8, 8 2s are 16, 160, which gives us the final velocity squared equal to 176. So our final velocity will be the square root of that 176. Now be careful, because when we take the square root of something, we're going to have a plus or a minus answer, and common sense tells you that since everything's going in one direction, we're going to have to take the plus answer. So the square root of 176 gives us plus 13.26 meters per second. Now to be consistent, you can see that all the data we haven't used a decimal point in that data, so we can put our answer down as 13 meters per second to be completely in tune with all the data. Let's take a look at our second motion problem. The velocity of a yacht at a marker buoy is 15 meters per second. It accelerates at 2 meters per second every second as it passes the marker buoy. Find the yacht's displacement from the marker buoy 10 seconds after it passes it. Well, once again, we stick to a routine. We put down our ordered list of all our kinematic variables. U, the initial velocity, v, the final velocity, a, the acceleration, s, the displacement, and t, the time. Read the question again and fill in as much data as you can. The velocity of the yacht at the marker buoy is 50 meters per second. That will be your initial velocity, 15 meters per second. It accelerates at 2 meters per second every second, so we can put down our acceleration. Find the yacht's displacement, so we have to find the displacement of the yacht after it passes in a time of 10 seconds. So we have the following: u, a, s, and t. So we'll look for an equation from our list which has got u, a, s, and t. So which one are we going to use? U, a, s, and t. This one here. So put down the equation. S equals ut plus 1/2 at squared. And just put the numbers, because the s, the variable we're looking for, is on the proper side of the equation, so we don't have to rearrange. S equals bracket 15 times the 10 seconds plus bracket 1/2 times acceleration, which is 2, times t squared, 10 squared, it's going to give us 100. So the brackets will become 150 plus half times 1 is 1, 1 times 100, 100. And therefore the displacement S is going to be 250 metres. Now, there's an alternative way to do that, only involving 2 steps, because we could have worked out a displacement from this equation up here, S equals a half into U plus Vt. But there's one thing which is stopping us finding that, and that is the final velocity. But we've got enough data to find the final velocity, because we've got U, A and T. So we could do this in a different way, which I'll show you in red here. We could find the final velocity, V equals U plus AT, from that equation. So final velocity equals initial velocity, 15, plus bracket acceleration, 2 times the 10 seconds. So we're going to have V is going to equal to 15 plus 20, which is 35 metres per second. So now we have the V, 35 metres per second. And then we can go ahead and work out our equation, S equals a half U plus Vt, the average velocity times the time. So S will be equal to 1/2 times the bracket U plus V, so it's 15 plus 35, and multiplied by the time, 10 seconds. And if we multiply that out, we get 1/2 times 15 plus 35. 15 plus 35 is going to give us 50, so a half times 50 times 10 is 25 times 10 is 250 metres, which is exactly the same as we got over here, which proves a very important thing, that the kinematic equations will work in 1 step or even in 2 steps. Let's take a look at our final kinematics problem. A ball is thrown with an upward velocity of 6 metres per second into the air. Find the time it takes to get to its highest point. Now, we're not given much information here, so we put down our ordered list of kinematic variables as normal. So we put down U, our initial velocity, V, our final velocity, A, our acceleration, S, our displacement, and T, our time. And let's fill in as much as we can here. First of all, the ball is thrown with an upwards velocity of 6 metres per second into the air. That's your initial velocity, 6 metres per second. What's your final velocity? Well, when the ball reaches its highest point, it's going to have no velocity. So we can say at the highest point, we're going to have no velocity, 0 metres per second. What's the acceleration taking place in this motion? It's acceleration due to the force of gravity. So we're going to have that to be minus, because it acts down the way, minus 9.8 metres per second every second. Do we know the displacement? No. Do we know the time? That's what we're after. We're after time. So we're looking for an equation with U, with V, with A, and with T. So let's go and look at our equation list as usual. So something with U, V, A, and T, and it looks like it's going to be a simpler one here. V equals U plus AT. So V equals U plus A and T. But you can see we're after the time, and the time is not on the correct side. So we have to rearrange by taking the V and subtracting the U from both sides to give us the AT. We have to learn this move. Then to find T, we have to divide by the acceleration. So put a bracket on this, V minus U, divided by the acceleration, and that should give us the value of the time. So we'll put the numbers in then. V, the final velocity, is going to be 0. Take away the initial velocity, which is going to be 6, and we are going to divide that by the acceleration, which has got to be minus 9.8. So that will give us the value for T. So all we have to do is put T down and put down what it says in the calculator, and the two minus signs cancel, and we're left with 6 divided by 9.8, which is going to give us a value of 0.6 seconds. So time equals 0.6 seconds. And that's some 3 examples of how we use our kinematic equations to work out motion problems.
Physics is wonderful. Physics is cool. Physics is wonderful. Physics is cool.